13 talks about the t-test for one sample. In Section 2, it talks about the sampling distribution of t and compares it to the standard normal distribution. In Figure 13.1, it shows various t distributions with various degrees of freedom. The first one has a degree of freedom of 4, and it's a less concentrated curve. The degree of freedom that has 10 is a little more concentrated in the middle, and then the last degree of freedom is infinite, and this curve is the same as a normal distribution for z, which is the population standard deviation, and is the most concentrated in the middle. All t distributions are symmetrical, unimodal, and bell-shaped, with a dense concentration that peaks in the middle. When t equals 0, it tapers off, both to the right and left of the middle. The inflated tails of the t distribution, more so with the values of the degree of freedom, have the more important difference between the t and z distributions. So the table for the t distribution, you want to concentrate only on the critical values of t that correspond to the more common level of significance. When you're finding the critical t values, you want to use Table B and read the entry in the cell intersected by the row for the correct degree of freedom and column for the specified test. This intersected cell is the critical t. However, if you're looking for a lower-tailed test, you want to put a negative sign for that critical t value. If you're missing the degree of freedom in Table B of Appendix C, you want to use the row in the table with the next smallest number of the degree of freedom and round off to the next smallest degree of freedom. This will produce a slightly larger critical t value, which makes the null hypothesis slightly more difficult to reject, which will be good for other people viewing this study. Section 3 talks about the t-test. The t-ratio is a replacement for the z-ratio whenever the unknown population standard deviation must be estimated. The greater variability of the t-ratio. It will have the tails of the sampling distribution for t, which are more inflated than those for z, especially when the sample size is small, because as you increase the sample size, it comes closer and closer to the population curve. To make up for this, the critical t value must be larger than the corresponding critical z value. In Section 4, it talks about common themes of hypothesis tests. One main theme is that if some observed characteristic, such as the mean for a random sample, qualifies as a rare outcome under the null hypothesis, the hypothesis will be rejected, and otherwise the hypothesis would be retained. There are a variety of tests for an assortment of situations, such as Z, T, F, U, T, capital T, and H. So depending on what, you have to know which test you want to use. However, those will go further on in the chapters.